Good afternoon. How are you, students? Hope you are fine. Okay, today I am going to take a particular section from block over block problem. Okay, so this is my today's goal. That means the analysis of motion of block over block on a frictional surface when a constant external force is applied on the bottom block. Okay, bottom block that must be in horizontal direction. Okay, so before going to this our uh, going to the our theory, okay, first you must remember two things. First thing is about the free body diagram. Okay, free body diagram. So how to draw the free body diagram? How to draw the free body diagram? That means just to draw the all forces acting on the body. Okay, that means just to draw all forces on that body, on a body. Okay, that is the free body diagram on a body. Okay, then next the second thing is about the friction. Okay, about the friction also you should remember 2 points. You should remember the first point is when this friction arises when there is a contacting surfaces is present. Okay, contacting surfaces is present. Contacting surface, contacting surfaces. That means just imagine in our section, look here, this is the ground. Okay, this is the block. So in here there is a one contacting surfaces and this is our another, okay, another block. In both the cases this is a one contacting surfaces, this is also another contacting surface. Okay, friction, so friction may act on these two regions. Okay, first thing. Then next one is, the next point is, what is the duty? The duty of friction, or that means friction always resist, always, you should remember, always resist the relative motion. Okay, we will discuss that thing in our theory section. Okay, then the third point the friction section is what? The frictional about direction. That means the direction of friction is always opposite to the relative motion of the body. Okay, always opposite to, direction is opposite to relative motion. So these 3 points, okay, these 3 points you should remember. Friction may arises when there is a contacting surfaces, then it resists the relative motion. The third point is opposite to the relative motion. Okay, then we can discuss, we can start our section. Okay, so first we need a free body diagram. Okay, we can draw first that. That means this is my bottom block. Okay, and this is my top block. Okay, and this mass is given m1 and this mass also given m2. This mass is m1 and this mass is m2. Okay, then another thing is how to draw, just to draw the forces. That's a free body diagram. Then first one, the one force is what? That's a simply gravitational force. Okay, gravitational force, what is that? m1g. This is acts on this block. Then we know there is an external force in this direction. This is external force, F external. And we know another thing, this is a one contacting surface and in here also one contacting surface. So there must be a normal reaction. Okay, there must be a normal reaction. So this is the one normal reaction. Who is acting? This acting by the ground on this bottom block, and that is N1. Okay, then another thing is, this is another contacting surfaces between these two blocks. Okay, so this one is what? This is the another normal reaction, N2. This N2 is acted by this top block. Then another, how we can draw the frictional forces. We know there is a two contacting surface, so two frictional force must be present here, and we know frictional force always resist the motion. And so if this external force is in this direction, then what happens? Frictional force resist this motion. That means this is our one frictional force, and represented by FR1. Okay, then another one, one more contacting surface is present, this one. So we know friction always against relative motion. Okay, that means with respect to this block is moving forward. Okay, that means if this motion is like this, relative motion of this block with respect to this one is in this direction, then this FR2 is opposite to relative motion. So this must be FR2 on, in here must be here, action reaction pair, Newton's third law. So FR2, this FR, this is a one action reaction pair. Same like that, in here we know one M2G is there, one M2G, and this is also a contacting surface. So in here also there is a one normal reaction, this normal reaction by this bottom block on top block. That means this is our N2, this is our N2. So this is the free body diagram, first thing. The next thing is, we know the motion of the body, the total body always moves along horizontal. There is no vertical motion because this body, this M1 and M2 rest on the ground. So just to observe these two, we can say that there is no vertical motion. So M2G is balanced by N2. So what is our N2 here? N2 is actually M2G. Okay, then just observe this one, M1G acting downward, and N1 acting upward, and N2 also acting downward. So this vertical downward force that are N2 and M1 are balanced by N1. So this N1 is equal to N2 plus M1G. What is N1? N1 is equal to M1G plus our N2. What is N2? M2G. Then what is this FR1 value? FR1 value, this is a static friction. Static friction value varies from 0 to 1 limiting value. So 0 to that maximum value. How to find that maximum value? If we know the frictional coefficient between these surfaces, that is if it is mu1, so mu1 into normal reaction, this N1. What is that N1? N1 we know, these two. Okay, these two weights. That means M1 plus M2 into G. Then same like that. What is FR2? FR2 also has a range of value. That means 0 to that. In here, this is a mu2 is there. What is mu2? Mu2 is the frictional coefficient between this contact surface. That means mu2 into 0 to mu2 into this normal reaction into what is M2? M2G. So that means FR1 value, FR1 has this value, the range of this value 0 to mu1 M1 plus M2G, and FR2 is 0 to mu2 into M2G. So we should remember this one. Okay, then we know, okay, we can go to our problem section. So I am going to apply the force along on the bottom block. Okay, on the bottom block. So initially what is the situation? This is our external force is applied on this on the bottom block. Initially, what is the thing? We know initially the system is at rest. Then I am going to apply the external force in a such a way that this external force is keep on increasing linearly from 0 to some extent. So at that time we are checking what happens to the motion of these two blocks. So that is our today's aim. Okay, the during that means when the F external is keep on increasing, what happens to this M1 and M2, motion of M1 and M2 or these two blocks. So we can see that, okay, we can see that when we increase this F external, so initially what happens, this frictional force, we know frictional force always resists the motion, relative motion initially at rest. So this Fr1, what will do this Fr1? Fr1 try to resist this F external. So that means up to some extent this total block is total, that means M1 plus M2 system rest on this ground. So up to some extent. Then after that we can say that then we know our F externals keep on increasing, our F externals keep on increasing. That means, so that means after that time we know this M1 and M2 system moves on the ground, and we know this our F externals keep on increasing, and after some time we can see that at one particular force, this second body, that means M2 is start to slide over M1. So we are going to find these two expressions. That means when this total M1 plus M2 start to slide over, okay, we have to find that F value. Same like that, another F value, that means when the M2, that means top block starts to slide over M1. Okay, so that's our today's aim. That means we have to find these two values, then we can do every problem. So that means the first situation, this is our F external, that means our F external is less than F1L. That means, look here students, this is our block, this is our bottom block, and this is the top block, and this is the ground, this is the ground, and this is our F external, this is our F external, this is our F external. Okay, then our F external is F external is, we know F external, when we F external is applied on the bottom block, what happens, this Fr1 try to resist, that is the duty, that means always resist the relative motion. That means in here initially this is at rest, so try to resist this motion. But Fr1 is, we know that's not a constant value, but Fr1 has a one range of value from 0 to 1 maximum value. So when F external is increasing, so Fr1 can resist till this Fr1 reaches that limiting value, F1, F11, F1L. That means if our F external is greater than F1L, what happens, this total block starts to slide over. Okay, so that's today. That means if F external is less than F1L, at the time what happens? We know our M1 plus M2 system, M1 plus M2 system rests on ground. The first point. Then what is second point? So if F external is less than this limiting value, then what is our Fr1? Fr1 is equal to that external force itself. That means this F external doesn't reach its maximum value. Then we know the total system at rest. Total system at rest means this top block also at rest. You just check our free body diagram. At the time we can see that only one horizontal force is present on the bottom block. So if the total system at rest means the top block also rest, that means it doesn't have any acceleration. That means Fr2 value will be 0 in this time. That means Fr2 is, so that means when our external force is less than that limiting value. So our external force is increasing or keep on increasing. So if the frictional force at this location reached that maximum value, what happens? Then the total system start to slide over. That means, okay, that means if we increase the external force again, what happens? This force can't increase furthermore. Okay, that's our second point. That means if the F external is, that F external I represented by F1, that is equal to F1L. That means our external force reached that F1L. At the time what happens? M1 plus M2 system. M1 plus M2 system starts to slide over. starts to slide over the ground. Okay, slide over the ground, slide over the ground. Then we know this is our expression, this is our block, this is our figure, figure like this. Okay, figure like this. This is our F external, this is a frictional force, and this is also our FR2, this is also FR2, and this is what, this is our F external, and F external is now F1, and at the time what is our FR1, FR1 is F1L. Still the system only start to slide over, okay, not in motion. That means this FR2 still 0. This is our FR2, FR2 still 0, FR2 still 0. That means total system still at rest. Then that means what is our FR1? FR1 is our F1L. That means our F1. So what is that F1 value? What is the F1 value? F1 we know mu1 m1 plus m2 into G. Okay, we have derived. Then what is FR2? What is FR2? FR2 still 0. FR2 still 0. That means if F external is equal to F1L. So if our F external is greater than F1L, what happens? The system must move. That means this M1 plus M2 system must slide over the ground. Okay, so we are going to discuss that one, the third case. In the third case, that's you may get some confusion. Very important, look here. If our F external force is in between F1 and F2, what is F2? So in the introductory section I have said one thing, and we know initially the system now system is moving with the common acceleration. Our F external still goes on increasing. So at particular force, this M2 start to slide over M1. So that external force is F2. So what is F2? F2 is the external force in which M2 begins to slide over M1. So in that region, that means if the F external is in between F2 and F1, at the time we know what happens. The total body, that means M1 plus M2 system moves with the common acceleration, or moves together. Simply we can say moves together. Then how we can draw our figure? Okay, both are moving together. This is our F external force. Okay, this FR1 already reached the limiting value. Then this also moving means this, it has a frictional force. Then this is the reaction force. That means this is our F external, and FR1 already reached the limiting value. This is our FR2, and this is our also FR2. Hope it is clear, students. Okay, the next one, M1. Then what happens? What happens to our FR1 value? FR1 is equal to what? F1L, already reached the maximum value. Then what about our FR2? FR2 is equal to what is the force? Mass of this one M2, and we know both the body moves together, AC. So how we can find that common acceleration AC? That means what is the acceleration? Net force divided by total mass. So FR2 and FR2, these are equal and opposite action reaction pair. We don't need to mind. So only here is our F external minus this F1L in this direction against motion divided by total system mass M1 plus M2. So this is our AC. Okay, students, this is our AC. This is our AC. So that means M2 into what is AC? F external minus F1L divided by M1 plus M2. So by this So this common acceleration, just observe this one. This common acceleration, just observe this one. Common acceleration is equal to F external minus F1L divided by M1 plus M2. So that means with respect to the, if the F external is varying, our AC value must vary, just to check. Okay, so look here, in here also. So FR2 also, we know FR2 also not a constant thing. FR2 is equal to M2 into AC. When external force is increasing, at the time what happens, our AC, if our weights, if our this external force is increasing, what happens, our acceleration increases and FR2 value also increases. But we know FR2 has a maximum value. What is that? F2L. So up to that value, that means if the FR2 reaches the maximum value, up to that time, these M1 plus M2 system moves together. So we get that point. So when FR2 become F2L, FR2 become F2L, at the time what happens? At the time what happens? M2 start to slide over the, so that's our another section. That means if F external is equal to F2, that means at the F2, the total system start to slide over. M2 start to slide over M1. So that's the thing. That means M2 starts slide over M1. Okay, over M1. That means this is our figure. Okay, this is our blocks. This is our F1. This is external force. This is our FR1 already reached the limiting value, and we know at this force what happens, at this time what happens, our FR2 also reaches the that limiting value. What is that limiting value? What is that limiting value, students? What is that limiting value? This is the external force, F external. That F external is F2, and this is, we know, already reached the limiting value. This is also F1L, and this is what, our F2L. This is F2L, sorry, F2L. Okay, F2L. That means this is our F2L. This is also F2. Okay, F2L, F2L. So at this force, the M2 start to slide over M1. That means how we can express, how we can, so this is the, that acceleration, the maximum acceleration in which both the body can move together. Okay, what is that acceleration? Just to find that acceleration, that AC, that acceleration is net to force is F2 minus F1L divided by total mass M1 plus M2. So this is the maximum acceleration, maximum common acceleration can attain by these two bodies. F2L and F2L will be cancelled. Okay, action reaction pair. So how we can, what is F2L? What is F2L? That is only the horizontal force present on the top block. F2L is equal to that M2 into this value, F2 minus F1L divided by M1 plus M2. So look here, after that means, look here, F2L is non-value, F1L is also non-value, only F2 only. Okay, we have to find only F2 value. Okay, M2, all other things are known to us. Okay, then from this, after simplification, you will get this one, that F2 is equal to mu1 plus mu2 into M1 plus M2 into G. M1 plus M2 into G. Okay, this also very important. So if we know this F1 and F2 value, if we know F1 and F2 value, then we can easily find the problems. Okay, so we can consider one problem. Okay, that means, look here, just to read the problem. First one, there is a one ground, then one bottom block, wait, one block. Okay, then another block. Okay, this problem. Then another block. Just to consider another block. Then just to read the question. 4 kg block placed. This is a 4 kg. 4 kg placed over 8 kg. On the rough ground, friction coefficient between 8 kg and ground is 0.5. That means this mu1 is given, that is equal to 0.5. Then and between the two blocks is 0.2, that this mu2 also given 0.2. So just to find what is F1 value. F1 is simply, we know F1L. That means what is F1L? Mu1 into M1 plus M2 into G. So that means mu1 is 0.5 into 4 plus 8 into 10. So you will get 60 Newton. And what is F2L? F2 force. Just apply the expression mu1 plus mu2 into M1 plus M2 into G. So that means mu1 is 0.5 plus 0.2, 4 plus 8 into 10. Okay, G is 10. Just apply 0.7. This is a 0.7 into 12. So what you will get? You will get 72 Newton. That means if our external force is less than F1, what happens? Total system at rest. And if our external force is equal to F1, that means 60 Newton, then the total system start to slide over the ground. And if the external force is in between F1 and F2, what happens? The total body moves together and M1 plus M2 system moves together. And if the external force is equal to this F2, that means 72 Newton, then M2 start to slide over the ground. And if the final thing is, if the external force is greater than 70 Newton, all bodies moves with a separate acceleration. That means this M2 and M1 moves with a separate acceleration. Okay, students, hope it is clear. Thank you.